All right. So for anyone seeing this in posterity, welcome to reasonable coding. But it's not really called that anymore. We don't know what this is.
I think we can still call it reasonable coding.
Yeah.
Just change the format.
Yeah, we can just change the format. We'll need a brand though. I know you know some people that make good brands, so yeah, the implication is there. Anyways, what I wanted to show you folks today and was some hot stuff. I was building the website for abstract machines. This one, right? And I've been sort of writing about ontologies and other projects.
Can you share the screen here on, or should we watch the stream as well?
Oh yeah,
as the last time with the delay, or should we?
No, that's a very good point.
You share the screen here on Discord.
There's a small problem with me sharing the screen on Discord, and is that I can't share one monitor. I have to share my entire screen. Well, so what I can do is this will take some juggling, but I can share one window at a time, right? So I'll share my browser with you. Can you see my browser?
In Discord?
Yes.
Yes. Yeah, I can see it.
Perfect. So that way you can see the browser, and it should be fast enough for, like, you should see me swapping tabs. And when we jump into the terminal, then I'll share the other window.
That's good. And how does this go into a stream? Let me see. Oh.
I mean, we have our tiny faces.
Okay, in the stream you can see the whole thing. I see.
Yeah.
Okay, fair enough. This works. It's a bit redundant in the stream, but not too much.
Yeah, I can't really. Oh wait. There's a show non-video participants. No, I can't really not show my screening here. So on the right-hand side on the little block, then you will see the 4 faces. But well, could be worse. Yeah, so I was building the website, and I was creating some content in the Patreon account, and you'll see there's a couple of essays in here. And I realized that from the get-go, this was a shit platform to publish content on. They did reply to a tweet of mine where I asked for Markdown support on the editor, but how long is that going to take? I don't know. You can see that some of these things are not very easy to digest. It feels like a big wall of text. Like, how are you going to read all this stuff? The syntax highlighting is gone. There's no hierarchy on any of the content, right? So I figured, I'll just grab the Markdown files that I have for these things, right? Because I clearly was writing in Markdown, and now we'll just build a website out of that. So I thought maybe I can ask you folks, what have you been building static websites with? And you recommended me Next and Gatsby. I played around with Next for a little bit, and when I needed to do syntax highlighting, I hit an impasse, and it was an annoyance that I would also have to rewrite all of my Markdown files into React components, essentially, unless I bring in another sort of component of Next, which all of a sudden adds more to the required knowledge for using the tool to just build a static website. So I thought, okay, well, I could reuse Cactus, which is something I had built for exactly this reason in the past, and I built it in Reason, and it has the very nice property that you just touch a couple of empty site files, and it immediately compiles everything for you, following your folder structure and everything into a mirror tree. So all of your Markdown files end up as HTML, and if you have a tiny template, then you can do a very basic templating there. So it's 0 plugin, 0 configurability, but I see the end product, and I can work with that much more closely than through layers and layers of JavaScript abstractions that quite frankly, I don't have the time to learn. Can I learn it? Sure. I could sit down and go over a weekend over Next.js and invest into it and so on. But I figured
I guess the goal is slightly different, right? Like not trying to over defend the complexity in the JavaScript world, but I'm thinking of the main feature I got out of the other ones is the navigation without full reloading, while you still get like if you go to an address, a URL that is typically with several paths, and it loads properly, but if you navigate, it doesn't reload while you navigate.
Yeah, exactly. Nice. Yeah, that is nice. That is nice. That is definitely not a use case I had, right? But it is something that those frameworks do that I did not aim to solve whatsoever at all.
It also feels that that's only a problem if you have the kind of complex either UI or like just code that it will take time to load when you do a full refresh. That would be significant. If you have purely static content that is built in a nice, compact way, then it's not a problem for you. Like
if you have 2 megabytes of JavaScript that you need to load on every page, then don't load it on every page. Yes, that makes perfect sense, right? So clearly, Next was overkill for what I was trying to do. I just have a bunch of Markdown files. I want to show them in some way. However, it did show me something that I thought was really, really nice. And honest to God, I'm freaking out that the tool may not work during the stream, right? But it did show me that live reloading of CSS and of the page content itself, right, was really nice. I wasn't doing any JavaScript heavy things, right? So I'm not interested in preserving state while reloading components or none of that. I just want to save the file and immediately, like instantly see the change on the left, right? That's sort of what I'm going for here. So Cactus is a builder, it builds the thing and it's really fast at building stuff, but it doesn't do jack shit other than that. Its role ends the moment that it finished building. So the way that I've been using it before was that I just have some Python simple HTTP server to serve the files, but that meant, you do some changes, you manually trigger a build, and then you go back to the browser and refresh. And I know it's not that big of a deal, but if I can not do that, then I'll rather not. That's sort of how we're lazy.
Yeah. So I think the thing that tripped me up with Gatsby and Next.js that they're actually not static site generators. You can render static site with them, but the way most people use them, and they're actually like progressive web app generators to call them.
Oh, okay.
So I think the idea is, or I'd like to think that the idea is that they want to create a tool that can both like appease the Hacker News like people and the JavaScript type framework people. So Hacker News is like notorious for like, I needed to load more than 20 kilobytes for this website. What the fuck's up? And whereas the JavaScript developers, they want their React, they want their CSS and JS and all those things. They want all the tools. And I think this is like in between. Like I think the goal basically is to get a good score on Lighthouse, basically.
Yeah. Speaking of which, the score. I did try that, and I've used Lighthouse as a test. But I wanted to search. Maybe we could find the original post for Next.js on Hacker News. My guess is that we won't, or at least not that quickly, to see some of the reactions.
I think Next.js wants to be simple for the one using it. Like it's easy to get started. But I think it's, I assume, I don't know the internals, but that it's a pretty complex project behind the scenes. But I think the goal is that like the initial load of the website should be really small and should be really fast, and then do things like pre-caching routes and all those things.
Right.
To make the websites almost seem static with the instant loading.
Yeah.
And so it's a kind of like in-between thing. It's not it's not a React app, and it's not a static site.
Right. And that makes sense. I mean, there's definitely a use case for a tool like this. I just felt that they take this very naively, but I had about 110,000 of lines of JavaScript code to build a bunch of Markdown files.
Yeah.
Right? That's essentially what I was trying to do. And I felt, why do we need this much code to compile some Markdown? And it wasn't just a single binary, right? It was code that needed to be interpreted before I could compile this thing. And now there's definitely a use case for that, as you folks have pointed out. But I honestly, I did not feel like it was justified in my case. So instead, I did what every good engineer does, which is don't use the thing that's already there. Build one from scratch, right? Yeah, that's what we get paid to do.
That's always justified, right?
Always, yes. No, and honestly, I don't think that what I build is justified, right? I think I just wanted to build it as well. I could have used Cactus. I could have used refresh the page manually, but it felt so nice to be able to do like, oh, okay, now I understand how you do this thing. Like I learned a couple of things. But anyways, without further ado, what I ended up building is called HotStuff. And the README is 80% Cactus, but I also was very mad at everything, so I wrote it like a little aggressively. Justifier already sets the mood there. It's a no nonsense, right? It makes no assumptions about how you structure write your content. You can do whatever you want there. It's essentially a drop-in, right? There's no plugins, and I expect it to have no plugins ever. So it just does one thing. It's composable because it doesn't matter how much content you have on different places. If you clone a bunch of blog repositories together into the same folder, you just need to run the command from one level app, and then it just builds everything again. And this is something that I've essentially borrowed from Dune. This is how the Dune build tool works. And it's incremental, as in it does this aggressive caching of everything that's built, right? So that it only rebuilds the step that needs to be done. And this is something that I'm borrowing from Bazel, which is essentially what Bazel does. Yeah. So it works.
I have a question.
Go for it.
I think I noticed this in Cactus as well, because I tried to use Cactus a while ago, and I remember I didn't know how to install it. I'm noticing the same here. You seem to have a command called HotStuff.
Yes, I have an installation instruction here, but right now it requires a running Rust toolchain. Like I haven't spent time publishing a binary that you could run. So if you do happen to have a Rust toolchain, then you should be able to do this and get HotStuff installed.
So you're making install. So installation is also building it. It's build and install. And also
as it is right now, yeah. Like if it was published as a binary, then you would just download the binary for your architecture and that'll be it. Okay. I thought of publishing this to NPM maybe, and you can do that. The Rust ecosystem is so nice for these things, for the whole JavaScript interop. But I haven't looked much into how to publish like a Rust binary as an NPM package that you just yarn global add HotStuff and you get it.
I mean, you have the problem that then you have to compile it for all the architectures, right?
Yeah, but I can do that at this stage in CI. And okay. Rust has fantastic support for cross-compilation. Mm-hmm. So if I wanted to cut a release from my machine, I could also just build one script that compiles it for like, I don't know, 20 different target machines. Then good. You just download it. Yeah, it's really nice. Good.
Okay.
Because Cargo is kind of like, I don't know if it's inspired or NPM was inspired by, but I see many similarities like between the Rust ecosystem and the JavaScript ecosystem. They have it kind of same of like, there seem to be plenty of dependencies in Rust as well compared to other languages. Like there's probably a crate for everything, right? And part of that has to do with the community, I guess. There's a kind of big community that is growing really quickly.
Yeah, that's a good point. If we dig into the Cargo TOML here, like I am using a couple of dependencies, right? They have for example, Chrono. It's a library for working with time. There is something that the Rust community, as the community has done, or but I perceive it to be done in this way, that I don't think that JavaScript does, is that they focus efforts on building one thing really well. That's what I feel. For example, they have a single runtime for asynchronous, execution of things called Tokyo. And there's layers to Tokyo, and some people contribute to different layers, right?
But they have more runtimes than
right,
Tokyo
yes.
for async, right?
That is correct. Exactly, that is correct. But if you look around, you have the main runtime that everybody seems to be using, right? Most of the documentation you'll find is for that one, and then there's the rest, right? But you don't have 40 different implementations of the same thing that are more or less at the same level that you don't know how to pick from. There seems to always be a clear winner for every task. And I understand that this is not like a rule of thumb, right? But it's what I've found to be true so far. For example, you have a couple of libraries for building CLI applications. StructOpt is a little layer on top of Clap, and Clap seems to be the tool CLI building library, right? There's some others, but that's the one that you like see used around.
I haven't used Rust, but I've heard of both Clap and StructOpt. Clap seems to be like the lowest level one that a lot of other tools build on top of, right?
Yes, and they do that as well. Log, for example, is just an interface, right? It's a login interface that has pluggable backends. There's a lot of backends there. The one that seems to be the most popular is Fern. Of course, other people have used other things as well. There's Hyper as an HTTP server. There's HTTP as just a library that defines HTTP types. And that's something that I haven't seen in JS ecosystem, but I'm a little detached as well. So if you find that there's something that missing there, let me know. Like, is there a library that says, this is just a definition of the data structures we're going to be working with for this protocol? Like, for example,
I am guessing that is not something you do very often since you don't have types. I mean, the closest you can do is like, I don't know, schemas that you can use for the GraphQL or something like that. I don't know. I don't suppose that's very common. I have a couple of comments and questions though. One of them is, I noticed some of these that you're mentioning, I have to say, they are included in the Node core in Node.js, which
like
is
one
reason you wouldn't see these things here, right? Like you have like the coloring logging with chalk and things like that, but to be fair, most people just use console log and then you can add something on top, but it's kind of super included. Same with HTTP. I mean, HTTP is part of Node and a couple of other things are so
yeah, exactly, yeah.
I guess in this case,
I mean, since Rust is a general purpose language, but it's also much lower level than Node. I think you could say that Node is more specialized towards mostly web development, whereas Rust can be used for everything from to like, what do you call it, like a machine low level stuff to building web apps.
Yeah, and then I have a question about the features field in the configuration for how does that work?
So you can define a package, right, like Tokyo, to have different features that includes different sections of the source.
Yeah.
So you're essentially saying when you compile Tokyo for this project, include the macros like submodule and the TCP submodule and the runtime core submodule.
So it is a kind of tree shaking.
If you want to call it that, yes.
I mean, very manual, so it's not tree shaking
exactly,
at all.
Yes.
But you're trying to make sure that you don't get the entire bundle of the library into your build.
So,
or is it like you pick the leaves yourself before you actually don't need to shake anything at all?
This is more like you will have tree shaking at the linking level because the symbols that are not being used are just discarded, right?
That's good.
But this is more to say there's certain language feature level things that are included in only certain parts of the library. For example, certain types or certain macros that are not really part of tree shaking whatsoever because they disappear at compile time. But this lets you say, I'm going to be using this subset of this library. Not all libraries do that, but libraries that are really big do that. It's kind of like adding this would be like a way of saying Tokyo-macros, Tokyo-TCP, Tokyo-time. But just a different library. Okay. But yeah, it is a way of...
What is the motivation then? That's my question.
So different features may require different dependencies.
So you have to know that?
When you're trying to use some of these things, right? If you want to use the time constructs that Tokyo comes with, the documentation points you to this particular feature. We can try to do that. Tokyo time.
But does a feature specify something other than the base library? So you need, because Tokyo is a runtime, right?
Tokyo is like a lot. It's so big. It has so many layers to stuff. Yeah. I thought it was more like, hey, this is the tiny like libUB asynchronous core, but no, you have the runtime, you have some extensions around it, like for working with time constructs, for working with sockets.
Yeah, because I know there are several line times for us. I know there's like an Erlang-ish one for us as well. So
yes,
you can use
have
different kind of runtimes.
The actor runtime as well.
Yeah, exactly.
But I think this is one of the lowest levels. One like Actix, for example, gives you this process, this actor, right? And that already is one layer above what you can do here, because you don't have to necessarily have mailboxes, for example. So you don't have that overhead and so on. But yes, as you were saying, Fernando, as far as I've understood it, right, when I was looking for a way to delay execution of, let's say, a thread, right, like a green thread, I just search around and I land here and it says, oh, you need to have time. And then the compiler will tell you, you need to enable this feature, right, to use this thing. There may be more to this, like you can search, like Rust feature, actually cargo feature.
This is interesting in the sense that it goes into what we are talking about, potentially doing an analysis of model systems. Because to me, as you are, from what I saw in that documentation page, it feels that this is a namespace within the Tokyo package.
Yes.
This is how it feels. And from if you go back to the other screen, you have like there the imports, right? And you have the use Tokyo time delay for, right? And time in that case is definitely like part of the namespace, right?
So maybe the whole point of features is to be able to reuse the top level namespace.
Yeah, this is how I'm feeling about it, right? So it is not a feature at all. Like I feel it's a misnomer. It's like you're importing a sub package, right? Like it's very similar to what you would do in like Node if you have a require of a package / something.
Right, with the path there. Like I guess in this case.
But isn't that also an NPM feature with like namespacing? Am I wrong? Because you can do.
Are you thinking
about import
the
package when you use the at /.
Right, but you're thinking about the scope packages. I could say that is different than namespacing, because in that case it's just that the package, you own the root of the package and name. But the namespaces essentially could be that you can require a script deeply nested into the package, right?
Yeah. This is stating that some of the rules for features are that they're gonna be chunking out what dependencies you actually need based on the features that you're gonna be using. So it's a way for you to have a single cargo tom file at some point, right? And say, I need to have all of this stuff, but this stuff is going to be used for this feature and that one for that feature and so on. So you let your consumer determine what transitive dependencies you're actually going to be pulling. I wonder if there's a reason that this is not done automatically.
Yeah, that's exactly my feeling about this. It's like if I am going to do Tokyo ::, whatever, : my feeling is that : whatever in the middle should automatically be affected by the builder or importer or whatever tool, I don't know, which takes care of that. But
is Rust a language where people want things to be done automatically?
maybe
some things.
This feels like something that is very easy to deduce, right?
Yeah, there's a difference between like what you actually do with the computer versus just the developer experience.
Yeah, that's my thinking.
But is there any reason you chose to use Tokyo? Because isn't there like a actual like standard async thing?
Yes. Full disclosure, I didn't know that there wasn't a standard async runtime yet. Like there's been talk about, the async and await syntax in Rust for such a long time, like a couple of years actually. So I just went with the one thing that I thought was still stable. All right, Tokyo's still there. I'm just going to use that.
It's not done yet.
Yeah, exactly. And it turned out that I could write a lot of code without having to write Tokyo at all, which was great because it injects itself into the standard syntax. So it is interoperable with it, which is very nice. But yeah, here it says that, high-level packages like iron or piston, don't know what they are, may want the ability to create a number of packages for easy installation. In some cases...
So this might be important when you install them, when you download them.
Hmm?
You know what I mean?
Can you elaborate?
It's saying that it may want the ability to create a number of packages for its installation. So if you want to import only one part of Tokyo, and you put that in your file, in your TOML, I think it was called,
cargo,
then maybe only those parts of the crate are downloaded.
Very possible, yes. I haven't checked the cargo folder to see what actually is downloaded, but yeah, it's very likely that it's optimizing that. But then again,
Node modules 2.0.
Sorry?
Is it like the Node modules 2.0?
Oh, there's a Node module 2.0?
No. I mean, no. That's
all right.
Saying like that the
it's called
what do you call it? Do you call it the cargo folder? Is the cargo folder equivalent to the Node modules folder?
Let's take a look at that, actually, if you don't mind. That could be interesting.
So especially I have a cargo. I don't have one in the repo, right? But I do have a registry.
Maybe the handle dependencies differently. I don't know.
Yes. Ooh, gonna be a little big.
But I mean, being a front-end developer using npm, it's not. It doesn't seem that much different.
No, I guess it would be closer. Yeah, it would be closer to Yarn and PNP. That you have this like top level cache of all the packages that are hashed. Yeah. But yeah, that's some of the things. So if I go for Tokyo,
the biggest difference I notice when I move from different package managers used for like applications is the fact that most languages doesn't have an actual CLI you use to interact with your application to actually install the packages. Like if you're using Tune, or if you're using I don't know, maybe it says Tune, or like Stack in Haskell or Cabal, it's mostly as you editing the actual file, the stanza, whatever you want to call it, to add the packages. So you edit the file and then you run the installation again and then it gets installed. Whereas the normal way to do it in like front-end or Node is just npm install, npm install.
Yes.
And then the stanza get updated. Here it's the other way around.
Honestly, I kind of missed that from JavaScript. Like just, I thinking it was in Ruby as well. You could do gem install and something like save, and it will just save that to a file. And that's great because I don't have to like open the thing. I know it's a very tiny thing and you do it once in the project, but you remember those things. Yeah. So anyways, I picked a couple of dependencies, doing a little bit of research, and I had to learn about the ecosystem as I was doing this.
Did you try using Sola?
Sola?
Which is a static site generator written in Rust?
No. At this point, I was like, I'm just going to build it. Whatever.
Yeah, you want, yeah. Okay.
I did, yeah. No, but I will give it a shot. The Sola RS, I guess.
Sola with a Z.
Sola.
I think this. I don't know what the site is. So getsola.org.
Okay.
It's blazing fast. It's scalable.
Nice. This is kind of like the thing I built. Great. All right, I guess we could stop the live stream, and I'm just gonna go use this instead.
No.
No worries. Yeah, but I will have a look. It's interesting. I would like to see how they're packaging all these things, even if it's just.
They said that they had 0 dependencies.
Right. Yeah. They definitely have a statically linked binary then, and they build it for every architecture.
I'm not saying they should use this. I guess it's the only like static site generator I know from Rust because I've been into the checking out different static site generators.
I understand.
I remember from being in Rust.
Cool. I will have a look at this.
You can even use Nix to install it. You see.
Huh. I think I'm more interested in how they're doing some things at the code level. Oh my god, this already looks like a big project.
I think it is a big project.
And they have library load too. Okay, let's see their library. Oh, come on, seriously? Did you have to do this here? Jerks. Yeah. Hey, good. That's nice. Oh, there's Ugo. I remember Ugo. Cobalt. Yeah. I think I'm gonna rebrand this as a documentation compiler. Definitely not a static site generator. Anyways, let's just get started. So I'll swap to the terminal now and show you how it sort of works. Then we can walk through the code.
I need to grab another quesadilla. I'm dying over here. Right back.
Cool.
I'll take the chance. I'll be back in 1 minute as well.
No worries. Is there anybody listening? I mean, not you folks that are in the call. On Twitch. 6 minutes. Who is this human? Hello, Vega. The picture is so small, I can't really recognize you. What's up?
Hello.
Hello again.
And I'm back.
Cool. String failed to start. Can you see my terminal?
Yeah.
Yeah.
All right. And ignore Discord. All right. So there's a HotStuff tool.
Vega said hi in the chat room.
Yes.
Hi, Vega. After you say hi back, go.
And it's a little bit like, I'm going to make it a little bit wider.
That's good. Looks really good now.
Yeah. So this is the tool. It essentially does two things: build and serve, right? And when you build it, it does this incremental compilation of everything in the site. It has no in-memory state, right? So it has to be fast for cold starts. And then you have serve. So I'm gonna call it first with build. And done. That took about 11 milliseconds. The site is not that big, right? But it does copy a lot of assets around.
11 milliseconds is orders of magnitude faster than what I'm used to as a JavaScript developer. Literally orders of magnitude faster.
Literally, yes. Yeah, I guess that even like I remember back in the day, Browserify had a good cache plugin, right? And it was fast. It was like 150 milliseconds to recompile the app, right? But I mean, we're talking 7 years ago or so. I don't really know how things are. But yeah, because you have the runtime, then you'll never get this sort of speed. Anyways, so it ran the thing. As you can tell here, there's a lot of blue commands. And right now I'm just dumping out the data structures that I'm using to represent the individual commands, right? Like create this folder, copy these files, this is the input, that's the output, and so on. But if I run it again, it does nothing. And you're like, oh, why isn't it doing anything? So if we go to verbose, we'll see a lot of output. Oh, right, sorry. Yeah, I'm having some issues with the flags. For some reason, verbosity goes before the command. But you'll see that it's essentially getting cache hits on every single thing that we have there. Which means it's... realizes he doesn't have to do any work.
What could happen if you manually remove one of the files from the build folder?
Interesting. Let's break this. So this is the build folder. I'm gonna remove the index, right?
Cool.
I'm gonna build again. Ready?
Do it verbose. Do it verbose so we can see everything. This is great.
I know, right? Yeah, it was so fast, and he just built that thing. So here's the thing that when I realized it worked, I was like, no, that's awesome. So
let me tell you something. This is so fast that you could live reload.
Yes.
And still hit 60 frames per second in the browser.
Yeah. I could literally be forcing the frames to you. Anyways, so I have this template that I built for the posts. If I show you my posts, they are just a bunch of markdown files, right? And of the things that I have in Patreon. So for example, I opened the last one. This is just, markdown. Vanilla markdown, there's nothing else. There might be a little bit of HTML here and there, but I don't think there is in this one. Scanning very quickly, I don't see any HTML. Yeah, it's just markdown, right? This and every other post, because they are inside the post folder and there's a side file there, will get compiled. This asset will be copied on the same structure, right? And all of the compiled posts will be templated using this template. This is a very, very small piece of logic that we have, right? Where if you have a template, then the template itself will be used instead of the document, and the document will be put in here. Wherever you put this stuff, that's where the document will be. Right now, it's...
Sorry, may I interrupt for questions, or do you need to wait a bit more?
Just ask, it's fine.
Cool. I have two questions. One of them is, what is this template format that you have here?
Oh, this is just HTML, and it happens to have a tiny string that you have to put. So
this is a regex that you run and you replace that string.
Kind of.
With something else. So it's not really a template language at all.
No, there's no template language. It's just...
Got it.
Yeah, it's more like string templating.
Got it. So that's question number one. The second question what was the data format in the file that you just showed of the template and package?
This is just vanilla S expressions. So you can highlight it with Lisp if you want. But like the assets...
So you have a Lisp parser as part of your...
I wouldn't say I have a Lisp parser, but I have built a tiny S expression parser as part of this, because my Googling is not good enough and I could not find one that worked. I just said, well, I guess I'm going to have to build this too. All right, sit down and build it.
Should be easy enough, right?
Yeah, it took a couple of hours. And it was mostly learning there's a parser combinator library called NOM, N-O-M, right? That they have this little monster logo. It's like nom 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 eating your bytes.
Yeah.
Kind of cute. Yeah.
This is literally, sorry for the tangent, but this is literally what we have to do. We have to do a stream in which we get a kata that is something like this. It's like just parse Lisp, like very small subset of commands. And then we have to do it in JavaScript. Then we have to do it in a new language, all of us at the same time.
Yeah, exactly.
Kind of like, and then compete to what happens.
Yes, but so we would have to define what external libraries are available.
Though that would be kind of the I will say that's kind of the fun. You need to kind of like throw yourself into new waters.
Yes.
I guess at this point you touch like Rust and Go and Reason, so you could have an advantage over us. But if we go to a new language that none of us tried before, like I guess Kotlin, we haven't tried.
We could try it in Kotlin.
What happens if we try to, write small parser in Kotlin?
I thought you were saying that the three of us will write the same piece of code at the same time and then like compare. But in different languages.
Yes. No, in the same language.
Okay. But if it was in different languages, then I was thinking, all right, but then we need to level the field, right?
Yeah, it would be impossible. Yeah, I agree. It would probably be impossible because there's probably one that has a library that does it.
Well, Camel.
Yeah, I mean that's probably the one place where OCaml actually has a thing up on Rust. It's parsing X expressions thanks to Jane Street.
Yes.
I guess.
That was so easy to do in if I jump very quickly to
Please.
Source parser. If I go to the parser, then like I honestly just had to. Site. I just had to use the SXP lib0, right? And this gave me a data structure to play around with, and it was really easy in OCaml to do this. This is recent, but data tomato. You grab the file contents, you use this function, then you get a bunch of SXP rules that you can iterate over while you decompose the list. And if you find what you're looking for, then you save it somewhere, and then go on and so forth.
Ah, that's very nice.
Yeah, it was nice. I had to do something similar in Rust, but I also had to write this function, which is what I had already for free. Yeah. Anyways, moving on. What I was trying to say is that when I found that this worked, I was just thrilled, right? All of these posts that we have here, they all depend on that template, right? So when you grab a post, MD, and you sort of modify it, I just saved the file again, right? And you do HotStuff build, then it just rebuilds that thing. And it knows, right, that the input has changed for the compilation, and the template needs to be redone again, right? Because if you recompile the file, then you need to template it once more. Now, look what happens, right, when I modify the template. It picks up that it has to copy the template over, and everything else is a child of that copy. So by modifying the template, I automatically update all of the things that need to be updated downstream. And I was like, thank you. Yes, that works. All right. And it's still relatively fast, like 8 milliseconds. So that's
I would like to see you doing all the timing, but without the logging, to see how much is actually like logging and IO and things.
Oh, yeah, that's smart.
I think it's...
I guess I could add a quiet function.
CI flag or something.
Take note of that. It would be nice to do the walkthrough, and then we can add that flag together. Right. So yeah, then it's doing nothing, which is pretty nice. But that's not even the nice part about this. This build command is something that I had already done with Cactus, so I already understood the problem, right? You have sort of this file tree that you need to sort of traverse. You pick up where the site files are. You use that information to pick up what assets you need to copy and what markdown or HTML files you need to copy over, right? And then you continue iterate. So you build this build graph is the wrong name. It's a tree, right, of the build, and then you execute the tasks like top to bottom. The nice thing is that because the hierarchy is built as dependencies, the plating is dependent on the compilation, which is dependent on the template being present. Then you can just say, well, I'm going to grab each one of these compilation units and I can execute them parallelly, right? Because they are completely isolated. They don't depend on each other. It's like grabbing subtrees of the tree that are siblings. They have no dependency between each other.
Could you? Does this mean like, if I understand correctly, like you could say like the template is the trunk, and if there's no change in the trunk, then there's that you can actually like see if the parent in a tree has no changes, then the children can't have changes as well, so you can skip that branch.
Correct. So let's start seeing some code. So the main file is sort of the top level application structure. It defines the parameters that you can use, some of the help from using struct_opt, right? So we have some structures that define the input fields, and struct_opt has this nice way of giving you subcommands, which happen to also be just another struct, an enum in this case. And then for each one of these, you will have more more structs for struct opt. So the way that this is embedded is that if I move around a little less, the top level, command can have a goal, and the goal can be of one of these types, right? Either a build or a serve, and then each one of these will have their own sort of options inside as well. Now,
enums in Rust, they're not enums like in C# or Java, right? They're actually proper like some types.
Yeah. They're just called something friendly for the C++ people. Anyways, each one of these structs implements a function, and this means that the function, whenever you called, let's say a equals build up, like that. If I call a.build, then this is the same as just calling this, right? It's a syntactic sugar for sort of threading in a context across a chain of calls. It doesn't actually mean...
It's kind of like Lua.
Oh, really?
Lua is the same thing, but you
Nice.
can use a colon instead of a dot to implicitly pass the reference to the object you call the function as the first parameter instead of doing it manually.
Nice. I get a feeling that this is what Reason is trying to achieve, right? With the fast pipe sort of thing.
Operator?
Yeah, with this thing.
Yeah.
That eventually became this thing, right? But
I mean, that's what Perl does. You
Right?
pass self, even in Perl, you pass self as the first argument.
Right. Because in
Still
Python,
good.
you do the same thing
Right.
as well.
Yeah.
It just, like, coming from I mean, on my day job, I would never do something like this, right? I would actually go to like build up, and that would be a module name, then has something build a, right? Then pipe into the other thing and pipe again and so on. But this just felt so natural, especially because I know that this function is just, it's isolated from the data as well. Like, it's just sort of syntactically stitched together, but it's not really together.
I mean, the key is that it doesn't mutate. A.
Yeah,
Right.
you can also make it mutate by requesting this thing to be mutable, right? But that's because Rust is built for very low level shit where you can't afford not to mutate stuff. Anyway, so all of these structs implement some function, and at the bottom you have the tiny main function where we just like grab the struct from HotStuff, which now has a function call from args, right? That comes from struct up. And then we call run on it. And this gives us a lazy promise that we're sort of waiting for and forcing here. So this async and this await, they are the standard new way of doing promises and futures in Rust. But the fact that I have this tiny wrapper around there, Tokyo main, right, puts them inside of the runtime of Tokyo, and I get async for free, or for very little, I guess. Anyways, this function run is defined as implemented inside of HotStuff, and it just clones the context and calls setup login. And full disclosure, I've had to clone a lot of stuff because I'm using one data structure called pathbuff that is not memcopy able, right? When stuff is memcopyable, that means that you can grab the entire data structure and there's no pointers to any heap anywhere, and you can just duplicate that with memcopy, right? So that's what they call a copy trait. It's even highlighted in blue. There's a different trait called clone, right? That you can implement for your data structure to decide how you're going to copy this information, but you don't get the benefit of automatic memcopy or the speed of memcopy as well. And due to the borrowing of this information, for example, when you do call self.setup logging, this is consuming self. So you can't use it afterward. This is probably a rookie mistake on my part. So I just added a clone in there. So this will clone the data structure, HotStuff with everything inside. And then this call can consume it and just be done with that. Part of this is because if you have two different copies of something that points to the same heap memory, right? Then even though the copies look like different things, they are the same data, or they have parts of the same data. And you don't want to be able to allow that, because anybody can grab that, pointer to the heap and then change the contents. Which is...
I feel like I lost quite a bit here, but...
I'm a little bit out of my depth when speaking about this as well. So it might be that I'm not explaining very well.
No worries.
All right.
But that's the thing, the way it makes me want to learn Rust is like you actually, like when you're doing web, you're not really talking to the computer. Here, you're actually talking to the computer.
Yeah.
Like
Trust me, the computer, very stubborn.
Yeah.
But this is basically the idea of the borrow checker, right?
Yes.
Like you borrow a value and you can only consume it once, and when it's consumed, you can't really do it again.
Right.
And this is what we call linear types.
I guess it will be
or
something
affine.
like
I think it's called affine.
affine types.
Affine types.
Precisely.
But, it's not really. Yeah, it's really super important.
Two categories.
Fine. You're talking topology now. Look at you. Wait a second. So okay, let's rewind a tiny bit so I don't miss it completely. So you have a struct HotStuff,
Yes.
right? And then for that struct, you implement a series of functions, including this run function.
Yes.
Which it's kind of similar to a method in a class, but it's kind of ugly to think it that way because we don't like classes. But you could say it's a method of HotStuff, right?
I like to think of it as traits are like type classes, right?
Yep.
With an implicit context. Something like that. That makes me feel clean.
Cool. That's fine.
Right.
So I'm guessing that for this function to run, you need a self. And that self is an instance of the struct? The struct?
Exactly. That's correct.
Where did you get that self from?
But this is just the definition, right? So when you call HotStuff, you'll pass something in, right?
Yeah. So that self essentially is the translation of this into this.
Yeah, that I understood. But if you go to the bottom, what you call it?
Right.
From args. So what is that doing? And
this is giving me essentially a self that I'm calling like this.
Okay, that is a good answer. Now, what is from args doing? I think I missed that.
Right. So from args is a function that, as you can see, is not defined in this module that is provided by structup. So structup is looking at my structure and building up a parser of the command line arguments, right? That will automatically read from standard in and make sure to clean up after itself to build one of these things and all of its nested sub command structs, right? Based on the inputs that you give it.
Okay, and that syntax, I have to be honest, doesn't look so good.
This one?
The hashtag.
Oh yeah. So this is macro syntax. You don't see it very often. Sometimes you see this derivation when you need to derive, for example, debug for one of your structures.
Debug being a trait.
Precisely, yes. That's what I'm saying. Like traits are like type classes.
Yeah.
Okay, so
you can really see that, like it's in Haskell. You always derive show to be able to print stuff. Yeah, exactly. Because this is like the same thing.
That makes perfect sense. But then structup is a bit more complex than that because derive, I'm guessing, is kind of a directive through the compiler, but structup feels like it's very userland. Like somebody wrote
exactly. This comes from the library.
Yeah. Got it. And the same in line 26, where you specify the functions for that.
Yep.
And you do that in the struct before the field that you want to populate with that particular value that you're parsing.
Yes.
Okay, fair enough.
When I think there's two kinds of macros. I've never written one of this kind. I've written the kind of macros that have a bang at the end. You'll see, for example, this format args over here. Horrible example because it's in the middle of everything. But you'll see that it's, format args, bang, and then there's some parameters to it. I've written macros like this, and this is just, moving stuff around, syntactical transformations.
Right.
As far as I know.
So then we're saying that from args, via these macros from struct ops, creates an instance of the HotStuff struct.
Exactly.
And returns that.
Exactly.
And this instance is populated with the information that you got from the command line.
Exactly. That is correct.
Okay. Now I think I follow completely. But I have one question still.
Go, yes.
Which is, why do you need to clone that struct?
Oh, yeah. All right. So that's the question, right? And I think this is lacking on my understanding of the borrow checker. So if you call self.setup logging, right? Because this function sort of takes a self, right? It consumes it, which means you're not allowed to use self after this anymore, right?
In this run function, I mean.
Yes.
In this code that you're right now.
In this function, which by extension would mean that you can't use it anymore wherever you called .run.
Okay, so clone function is duplicating the reference, is creating a new pointer to it. Or
no, it's it's cloning the data again. So it's not give me another pointer to the same thing, it's make a new thing that's exactly like this one.
So you have some memory allocated with this struct, right?
Yes.
And then that same memory, like you're copying that memory allocation into another space.
Yes.
And making a pointer to it.
So if I have A, and A points to this memory, right?
Yeah.
If I do a.clone, right, then this will clone that to another space, right? And then A will point to the same place that it was before. All right. So it's
okay.
So it's sort of duplicating this information. And I reckon that my program could be a shitload faster if I didn't do as much cloning as I do. But there's one data structure that it was a pain in the ass to work with, and maybe like rustations know not to work with it in this way, but I'm learning it the hard way, and that's path buff. And as you can see, this represents a buffer for a path, and I've used a lot of paths. So there's a lot of path.clone.
Okay, but give me a second. Buffer, I understand.
Yes.
But what does it mean to be a buffer? There you go. Okay, so that is a file descriptor, or am I?
No, this is a sort of string, kind of.
Is it a string that is specific to defining paths?
Yeah,
it's a type for paths.
It's a type for paths. Yes, you also have the type path, right? But the type path buff has some other properties, and it's the default. Or a lot of libraries seem to return path buffs instead of paths. Fun fact:
that is a strange
string is not mem copyable because string is of variable length, right? So you never know actually how big it is, which means it points to some memory somewhere, which means you can't copy. You have to clone.
Okay, but
this one though is mem copyable.
So you have a version of a string that is actually like fixed length. You declare the length when creating it or something like that.
Yeah.
Right. Okay, but I have a question though. Clone, I understand what it does now. You grab the entire data structure, from memory, you copy that to another memory address.
Yes.
What does copy do then? Because that
that
sounds what copy could do.
Yes, that's exactly. So the copy is a trait that can be derived, right? In the sense that if your data structure has fixed length and you can determine a compile time how big it is, then you can derive copy, and this will turn into a mem copy of sorts. So we'll just say copy like from byte 0 to byte 10 into this location, right?
Okay. So what you're saying is that clone is implemented by the user, it's not derived.
Exactly.
And it needs to have some sort of algorithm to know how the data structure is.
Right. So mind you that clone can be derived, right? Because if you use data structures that all implement the clone, then you can clone yourself, right?
Right.
But you need those data structures, and some of them don't provide clone, which means you can clone. Don't provide copy, which means you have to clone.
Right. So, I mean, I could I could say that in my opinion, clone is a bit of a misnomer. I would call it more like deep copy or something like that. You know?
Duplicate.
Yeah. I mean, it's
Yeah.
doing the same thing as copy. It's just derived in a different way.
Yeah, the fact that copy is called automatically but clone isn't when it's available, I think it's on purpose so you don't accidentally build a program that duplicates a lot of memory.
Yeah.
But I don't know. I mean, I'm figuring things out as well. Anyways, you're gonna see a lot of .clone whenever the borrow checker was like, no, but this thing that's been used already. I was like, all right, clone that thing, move on. Especially because we're working with a lot of paths here. But anyways, after we set up the logging, and this is vanilla from the Fern documentation, plus some color changes. I think we could spend hours just talking about how this works. So I'll just skip it. Then after that, we can access the command inside of the structure, right? And we do that with self.command. And we can call run. And that's because the goal implements run. So the goal knows how to run itself. I'm not sure if this is the exact way that like an experienced Rustation would write this, but from the code I've been reading, like the libraries that I've been using, everybody seems to define some enum struct and define some associated functions to that struct. If you do have functions in a module that are not associated to a struct, they're more like maybe static factory functions like creator functions or just helpers. So I'm trying to follow some patterns that I see in the wild, but if you're watching and you know better, just let me know. It's so hard to not fall into the old patterns of the live stream. Anyways, we have the goal and that has some options, and the build, you know, implements the build function, and the serve implements the serve function.
Vega actually had a comment. It said that you can run Clippy to find redundant clones, and borrowing will also make it faster at self and self. I don't know what and self is, but it sounds like it's a mutable instance because and is the mutable thing, right?
Right. You can run Clippy find the clones. Program will also make it faster.
You have a immutable.
Okay. So you know we can try making this refactor here. So instead of doing that, we can do this. So we borrow ourselves to call setup logging. And then I guess I could try to do cargo build. Building does take a while.
The argument should be and self.
Yes.
Oh, is this because if we pass an immutable reference, then the borrow checker knows that it won't mutate the reference, and then we're.
All right. I
Like
wonder
the
how much
knows that the compiler knows that we're not destroying anything, so we can.
Right.
Yes, that worked. By the way, Diga, thank you so much for that.
It did compile. Oh, awesome.
Yeah, it's already compiled and it worked. It did good. Look at that.
So by using the what do you call it? The and what do you call it? What's the proper word for?
I guess borrow.
Borrow.
I don't know. I would say borrow operator.
No, but just the symbol before self. What's the proper ampersand? Exactly.
Yeah.
Ampersand. Yeah.
Yes. Ampersand.
So the ampersand tells that the self is an immutable reference, and by saying something is immutable, it's more safe to use it. So then we can actually call the setup logging, and we won't consume. We won't consume the reference.
Right. We'll see how that works on some of the other code. But yeah, as I was saying before, you know, this implements build right here, and this is the code we're actually running, and the other one implements serve. So we're just keeping track of some time to be able to do an elapsed and see how many milliseconds it spent. We are creating a project model, and this is a tiny data structure that I put together called project. It does have 2 path buffs that I would love to get rid of. Have something that doesn't have to be cloned that much. And then, you know, it has a sort of constructor new, that doesn't take a self, so you can call project new, and then it has some functions on itself, like with root or with output dir to sort of update itself. And this is immutable. So you call one and then you change with the other, and then you're sort of like modifying data structure until you get a new one back. And after that, we're just going to the build graph module and we're saying plan build, and with that sort of project. You could argue that maybe this could be something like project plan build, right? Like that. But I felt that they were detached enough for it to be a dependency, one or the other. This is going to get very hairy very quickly. So I'll just finish this sort of build function, and then we'll get into the planning of the build. If we are passing the force parameter, then we just return the build, the graph that we created. I guess I can rename here graph build plan. That will be more accurate.
Could you try that? And if we disable the logging and the force, or we need the logging to actually log the milliseconds. But
my guess is that this logging wouldn't be much of a problem, but the logging that happens inside, right? Inside of the execute call, that will be the one that actually is taking some time. But I mean, honestly, we have to measure. That's the only way to actually know. Science. Anyways, we build a build plan, we plan a build, right? And then if it's forged, we just use that. If it's not forged, then we will compute a diff. And this compute diff will take care of grabbing the build plan and figuring out whether we're still gonna need to do all this stuff or what needs to be done. And then this if is an expression, so we're actually returning either one or the other one. And then we can call execute on that to get the artifacts. This could have also been refactored to just ignore that, just call there. I'm not sure if this is a little cleaner.
Is that the same syntax as in OCaml with the underscore, that you tell the compiler that we can ignore the...
Yeah, you don't even need that though. You can do this, and that should be okay.
Right.
But maybe it looks a little funky. I don't know, many ways of writing the same stuff. All right, so I'll leave that there, and we can go into planning the build. I made one that I shouldn't have. Or build graph. Save. So I'll open the build graph here. We have a build plan, which is deriving both debug and clone. And we have a node and a leaf. And this is your standard inductive tree, right? The only difference is that instead of using an inductive list, we're using a vector for keeping up more, more subsequent nodes. We're going to use this to sort of model the computation tree that needs to be executed to get your site there. Hopefully you can start feeling the over-engineering already. Yes. All right, so you can build a build plan by using start with and passing in a compilation unit. For now, let's just treat this type as something that has to be done. This could be like an A, right? And then it just gives you a leaf, and then you can use and then to sort of chain a list of tasks that need to be done. And this will make sure to either add the tasks or replace the ones that you had added before. Granted, this maybe could wrap this in another like empty node, right? So that you don't lose the tasks that you had added before. But the usage of this library is very, very limited at the moment. And we have a depth function that we can call on any build plan to get a vector of all the dependencies it has. What depends on it, rather than what it depends on. Maybe it's all the dependents it has. We have a tiny map function, right? That is, maybe map is not the right name. It started as a map, and then it added incrementality to it, so that if the current node, right, C unit, mapped over the function that you're passing in, the mapping function, is the same one as the old one, then you skip everything else. So this will be the thing that gives the incrementality And this maybe it's something like incrementally map or map incrementally or incremental
still
map.
map, right?
Yeah, exactly. But
signature-wise, I mean, it's
yeah,
still a map.
exactly, yes. But
that's fine.
You might be surprised if you run this and realize that your function has not run over every element.
The plus sign is just the type signature when you have multiple traits.
Precisely, yes. I'm saying that this function needs to be copyable, right? And it will run only once on this compilation unit. What did doc say for that? The version of the call operator takes a by value receiver. So fn once takes a by value, and I guess fn moot takes
this word, then you're saying that this word is kind of like a extra information.
It's just defining these variables like f.
Oh, there you go. But yeah, I was confused because word is usually, like in our languages, it's usually runtime thing, but this here is on the type system.
Exactly, yeah, and
Okay.
like in Haskell, you can use it for additional definitions.
Yes, yes. But not here is for the type system definitions. Correct.
Look at us flexing our polyglot muscles. Like...
No, but I'm just trying to translate in my head. Like,
I know, no worries. Yes.
What is that doing? Like, I thought it was part of the runtime code. Okay, I have a question, like maybe a bit dumb, but syntax-wise, or not syntax, but you have build plan : everywhere, and you're inside the build plan namespace. Is that necessary? Are you trying to explicit, or because it looks a bit?
So
noisy.
the build plan namespace is sort of this one, right? So I am not necessarily in it. I guess that there's some syntax I could use to do this better. I honestly haven't bothered to clean it, but yeah, my assumption is that as long as you don't have any identifiers that are already imported, then you should be able to do this, right? Sorry. It should work.
Right.
So the error I get here is that cannot find function tuple struct or tuple variant leaf.
Mm-hmm.
Wait, not here.
It was there. I saw it. Like if you go back to not searching, there.
Yeah, I was trying to open that big, but maybe I can do Rust errors. And let's just compile it and see what the compiler says. Yeah, I guess I could use.
Aha, that is what you should. Yeah, okay. Okay, never mind. It was just curiosity. Like I was betting that there was a way to like build this.
Yeah.
Be a bit more concise in Rust, but I didn't know what. Yeah.
I wonder if there's any problems with doing this by default, you know? Searching for the symbol within the namespace you're currently in.
Mm-hmm.
Maybe there is, and that's why they don't have it. I haven't figured it out yet. Anyways, the map does sort of the same thing you're expecting a map to do. And then we have one last function here, which is our breadth first iterator. And this took some brain power to figure out. Let me just try to do this so we can read this function and where oh cool. So this will take an immutable reference. Actually, this will not take a reference. This is a syntax for specifying the lifetime of values. There's another thing that I'm still trying to grasp. And of course, it can be changed into a build plan, and it will give you back a boxed iterator of dynamic size that has items that are references to compilation units. I will let that sink in.
What is dynamic? What does DYN mean?
And that means the compiler cannot tell the size of this thing at compile time.
What is a box?
A box is essentially a pointer to heap memory. So your program has some main memory where like some stuff is here, like constants, so on. And at compile time, you can tell what some variables we'll use, so you can allocate space for that there, right, when the program starts. But then you have the heap, is another chunk of memory that you have access to. You can grow and shrink based on your needs. And boxes in that are essentially chunks of memory in here that you need to allocate it at runtime. Or at least that's my understanding of it so far.
Isn't that something like in garbage collected language, most of them are like, if you pass by reference or value, some of them are on the heap and some of them are...
Yeah, for example...
But here, we don't have garbage collection, so...
Exactly. For example, in OCaml, I remember we were talking about the compiler for the OM language. Fernando, your language, O?
Right, yes. I was a long time ago, I forgot.
Yes, no worries. Yes. People know about the language, they remember. Anyways, remember that we were talking about boxed and unboxed values and how some of them will be like 0, 1 that represents, this is the tag. And then you have sort of the next thing, which will be like, it's an okay or an error.
Oh, okay. So literally a box like that. Okay.
Yeah, it's like it's literally a box like that. So this sort of means that some boxed types or some box values in memory will have this representation with a tag, and then there will be a pointer to more memory, right? And I think this specific meaning is the meaning that the box type has in Rust. So you say, well, I will have a value, but it has to be dynamically allocated in a heap somewhere. And they do the allocation of this memory through the drop trait. So if you implement the drop trait for some value, like for build plan, right? Assuming that we do some manual allocation of stuff. In here, you get a function, I think it's called drop, where you get a pointer to yourself and you can decide how to release this memory. Of course, you can see that if you do this correctly, and if you do it for most structures, then you can just return a new box that gets created automatically. And when that value goes out of scope, then the drop trait gets called, and then you get garbage collection. But not really garbage collection.
I know I've seen the discussion about box types in OCaml, like for performance reasons, especially like you wrote out there, like in the end, we just want the float. We don't want the float box with some kind of some type wrapped around it while running the program, because it's bad for performance, etc.
Exactly. I mean, you have one level of indirection that you could remove. Of course, when we think of it as, I have one float in a box, it's like no big deal. But you have hundreds of millions of them, then you have to duplicate all the operations you need for accessing them. And that can be a pain in the ass. It's technical for slow. Anyways, when we have a leaf, we just return a new box, right? That we just put our compilation unit in a vector and turn that into an iterator. When we have a node, we do the same for the root, right? And then we grab the dependencies and we iterate over them, and we sort of flat map over them by recursing. This is the closest I could come up with a inductive definition of this breadth first iteration. There's some tutorials out there about how to properly build iterators by implementing the into iter trait, right? And then by implementing the iterator trait. So then you could say build plan into iter, and that will essentially figure out how to return a new type, which is the build plan iterator, that implements iterator, that knows how to be iterated. And I spent maybe 3 hours trying to figure out how to do that. And then I said, fuck it, I'm just gonna recurse. Which I don't know if this might be one of the reasons this is slow as well. I don't know how expensive it is to build some of these iterators. We'll see. Anyway, so these are the functions that build plan implements. With that said, we can go to plan build. So plan build does this thing where it just starts with a compilation unit. And honestly, I think I should just go to the build rules and show you the compilation. And compilation units are things that you can do, right? Things that the compiler knows how to execute. It knows how to template stuff. You give it an input, an output, and a template. It will know how to do that. Give it a compile, and this could probably be compile markdown, right? It knows how to do that. You give it a copy, it knows how to copy. If you give it a creator, it knows how to do that. If you give it a cache hit, right, then you need to say what thing you were trying to build that hit the cache. You could argue that maybe this is not really a compilation unit, but it works. So yeah, we create a compilation unit for creating a directory, and we say, all right, I'm going to grab the project, right? And here's one of the other things that maybe we could try doing this. And I'm going to clone it. And I'm going to clone it to be able to get access to the output directory. So if we open the model again in here, you'll see that the output directory is a path_buff. And see if I can get the documentation for path_buff read. There you go. It's an owned mutable path akin to string, right? You can use push and whatnot on it, which makes me think that when I try to use this syntax to just share the project immutably, then I'm going to be sharing a pointer to some mutable memory that this object will hold, which means I can't do this. I can't share that. Like I have to clone it. So I'm gonna compile again, and we'll see where that gets us. I think I broke something. So I'm gonna
with the box with the O.
Yeah, I
did
think
for readability.
Yeah, I think that actually changed the meaning of something. So I'm gonna undo that. Where was it that we did it? My guess is that it was picking up the lifetime of this thing automatically. Or, yeah, there you go. So this says, I expected a path_buff, but instead I found a pointer to a path_buff. Okay. Consider removing the borrow. If I remove the borrow, then I think it might complain here. Or actually in this here. Yeah. So the value has been moved, which means it's no longer available. You can't use it. No. It belongs to this thing now. So now you have to figure out how to get one of the same things. So my guess is that it might be possible. Damn it. It might be possible to. Oh, output there is just a path_buff. Is path_buff just a? Sorry, I see Vega ask the question there. That's why I'm answering to now. Is this just a bad data structure to be doing what I'm doing? Should I be picking up something different, like just path? I don't know. We'll see in like 30 seconds. Yeah, maybe we can help. Let Clippy tells us what to fix. Anyways, once we have this thing, right, we can sort of find all the sites, and then we start a build plan with that task, and then we build sites. I think this reads kind of nicely. We don't have to do the node and then like leaf and stuff like that. It's just like embedded into DSL, if you will. So now we can go to find sites, and then this thing will take a root path and it will take a directory for output. FYI, the paths are going to get a little complex because some of these functions return you like relative paths. Some of them return you paths that are missing bits. Yeah, I'm still coping with that, a little bit of PTSD. But essentially, if the root is a directory, then we do the stuff. If it's not, we return an empty vector. So there's no dependencies there, right? If it is a directory, we're going to read it. We're going to turn that into an iterator. We're going to map over every entry, and this is like a dir entry sort of struct, and we're going to get the paths. And then we're going to partition this, this iterator of paths into a tuple of files and directories. If we get files, Where's the files? Sorry. Yeah. We're gonna build a root graph of this folder that we're working with by planning one site on this folder, telling it that this is the output directory and to look into these files. So planning the site will go through all of the files that are in this folder, and we'll try to figure out whether there is a site file or not, and so on. Now for the directories, we're gonna consider them possible subdirectories, right? Subsites. So we're gonna grab the directories, we're gonna turn them into an iterator. We're gonna filter out the ones that are the output directory. We don't want to build the output directory into itself. And we're gonna flat map that by finding sites at each one of these subroots. Now, something we're gonna do is that we're gonna append to the output directory, right, the file name of the subroot. So if you were in the top level and you find a directory called posts, then when you do the same work for that, you're gonna do it by using the output directory /posts. This was a little tricky to get nice, especially when you're like learning the path APIs. So this is pretty standard. I mean, maybe not standard, but it's not very complicated, right? You like do something with files, do something else with the directories, recurse files, let's do something else. Then after we have all of the subsites, we're sort of gonna check.
What's the syntax for the pipes? Was that, I think that was, is that a closure? Was the,
oh yeah, this is,
and,
this will be essentially like this, right? It's a closure.
okay. And the bang?
The bang just means not.
Oh, okay. Okay, yeah, makes sense.
Yeah, so if we do have a root graph after this, that means that the current root, right, is a site. So we're just gonna append that to the subsites. Otherwise, we just return the subsites. And note that this is a mutable operation, so we are actually mutating these subsites over here.
Is that if syntax like a one line like match?
Yes.
I mean, I understood it and I was like, that's awesome.
Yeah, I know, right? It looks so good. Yeah.
We got pattern match on the if.
Yeah.
Smart.
It's brilliant, yeah, because how many times do you want to check only if there is this one variant? You know what I mean? Yeah.
I mean, it's also like very intuitive thinking of it as an if.
Yes. I agree. All right, so let's look into plan site. This, I think, is the longest function I have, and it's maybe 190 lines of Rust. So we're gonna take it slowly.
Yeah. I think I need to jump off here. I haven't been able to spend any time with my girlfriend. And
oh yeah, no worries, that's fine.
I'm sorry, this is taking longer than I thought. I would really like to stay, but
no, that's fine. That's fine.
Have her as well. So
I understand.
You guys continue. I'll check this out later.
No worries. No worries.
Yeah,
We're
it's really fun going through this, seeing some actual Rust and understanding it.
I think I'm gonna learn a lot just by realizing that I don't know what I did. Yes. But
do you feel like it
sharing,
helps to be used to working a bit with immutability and coming into this language?
I think so.
Or is it just?
Yeah, I think that every time I have to type mute, right, it's like I don't have another choice. You know what I mean? Yeah. Like I try to not mutate stuff, but I realize that maybe that's what gives some programs the performance.
Yeah.
I don't know, like for example, instead of mapping over the tree immutably, like I'm doing here, which this is sort of like the kind of thing that we build in our sleep. Everything is recursive and inductive, so it's like type it out. Maybe this could be so much faster for larger trees if I was mutating in place the nodes, right?
Yeah.
Yeah.
It's kind of like OCaml in that regard. Like it's immutable by default, and then you use keywords to actually be mutable.
Yeah.
When you need the performance, I guess.
Exactly.
Which is kind of nice.
I think that's a sensible default. You know what I mean?
Yeah. Well, I'm gonna leave you folks to it.
Cool.
It's nice seeing you.
I think though is we can. I mean, I also need to do things, but I mean, if we can stop today at this point.
Yeah, I think it's fine if we
stop here. Yeah, we could continue some. Yeah, sure.
If you have maybe 5 to 10 more minutes, we can at least finish this function. So we like wrap this up and the next time start on the next thing. Otherwise, we're going to have to pick up from the middle of things. It's going to be like, oh, I forget how this is done.
Yeah, sure.
But I'll be less involved in the details. So we're roughly like grabbing all the files, checking which ones have, HTML or Markdown extensions. Those are our documents. We ignore the rest. We grab the site file that we parsed. I completely skimmed over the parser, but there we do the parsing and all. And we just grab the template if there is one, right? This is an option type. And then we grab the site, which is what we parse, and we ask it for the assets. And either we get something or we get an empty vector. And then if the assets is just a dot, that means we're going to clone all the assets in that folder. So we read all the folder contents and sort of map them into proper paths if they're files. This is just so we don't end up copying the entire subtree, right? Accidentally. Otherwise, we just put that in a vector. We filter out a couple of files. Like we don't want to copy the side files. We don't want to copy the HotStuff project file. And these are some other files that got in the way. Probably we can use an ignore file to ignore some of these things. And then after that, we just turn all of those into compilation units. Because they're all siblings, it's fine to keep them in a vector. They can be executed one at a time or in parallel, should be okay. And the next thing we do is we sort of grab the documents. We filter out the ones that are the templates, so we don't compile the templates, right? And then we put together a compilation unit for every document, and we ask, do we have a template? If we do, then we put a compilation, a templating after the compilation. So you template after you compile. And the last thing we do here, and we collect all of those into another vector. So now we have two vectors that are like all the assets that need to be copied, all the documents that need to be compiled. The last thing we do here is we create a directory that we're going to be compiling this shit into. And we ask, do we have a template? And if we do, then we copy the template over first. That guarantees that if you change the template, then everything that happens after that, like compiling the files, templating them, gets rebuilt. So this is how you build a document. We're doing some mutability here, like pushing each one of the documents into a single vector. But that's so that at the end of the day, we have one vector that has all of the units. And that's sort of what we return. The build plan reads, start, we create directory, and then copy and compile docs. And if everything went well, we have sum, right? We return a sum build plan, which means the bottom function can use that to decide whether there is some stuff to be done or not here, right? Is there a build plan? Yes. Then push it into the subsites. Else, just look into the other folders. And yeah, that's the build planning. It doesn't do anything. It just reads some folders and puts some structs together. That's all.
Cool.
But yeah, we can pick up from here or immediately afterwards. The next session, whenever that is.
Yeah.
Cool.
Cool.
Thank you, Dante.
Oh, no worries. This was a lot of fun.
So, yeah, thanks for.
Yeah.
It's awesome seeing, and thanks for showing us.
All right, now get out of my Discord. Go away. Yes. Yeah. Go do your stuff and whatnot.
Yeah.
Yes, we're gonna call it a day.
Cool.
Yeah.
It was nice seeing you, folks.
Take care.
Take care.
Yeah. Same to you. See you later.
Bye-bye.
Bye-bye.
Bye.
Yeah, and I guess now I can come in here. Oh yeah. If you like the stream, and this is like the part where I just advertise some shit. So if you like this stream, please support us on Patreon and whatever. You can click right there or right here. I don't really have any go anymore. But yeah, we do have a Patreon where we're building some tools. This is one of the tools, but mostly it's focused on building tools for information systems. Right now, one of the projects is building an ontology for the Dota game. If you're into that, then you can subscribe. That goes. All right, folks. It was a fun stream. There you go. It's going away. Have a good evening. Have a good weekend if I don't see you until Monday. Cheers.